Welcome back to another episode of the Klipshow build series. We are currently in episode 8. In today's episode, we cover a bunch of stuff that is getting us ever ready for a production-hardened application. We're covering a bunch. We start by going over what Postgres advisory locks are and the real-world use case that we ran into for applying them, and we go over that in detail, so that's really exciting. We then go into introducing some redundancy around rendering that TikTok iframe, which is crucial for our streamer alerts, and we're running into some of that while using it in our staging environment, and we'll go over that in detail as well. Not as fun, but something that's definitely necessary. We implemented our first recurring job using the ActiveCache backend, and we ended up making a decision to yank it out, but we still go over the original implementation, which does show a complete start to finish on what our intention was there. We just decided against it, which we go over in the episode as well. It wouldn't be a complete episode without doing some housekeeping around some flaky tests. And during our implementation of our OEmbed endpoint that we'll go over in the episode leveraging ActiveCache, we were able to use a very popular gem for testing called VCR. And if you're new to testing or if you haven't heard of VCR, this will be a really great highlight of the episode for you. And then we go ahead and implement that OEmbed endpoint that leverages ActiveCache, and we'll go over why that's needed in the episode as well. It's surrounding the TikTok preview that we originally had using in just the TikTok iframe on the Klipshow cards. We migrated away from that to a much more sophisticated, much more reliable preview method using the TikTok OEmbed API, but we run into some issues that we have to kind of account for, and that's what leads us to using the ActiveCache implementation. And that's really it. It's a jam-packed episode, so without further ado, let's jump into it. After pushing the functionality that we covered in episode 7, I had some of our viewers test the functionality with the streamer wallet and redeeming the channel points, and everything seemed mostly okay, except for a weird issue that we ran into every now and then. And I think I actually know that it turned out to be a race condition of updating the position column on our Klipshow models. And I wanted to go over this because this is a really good example of why you have to think these things through and know the different tools to use and stuff. And for some reason, this just totally evaded me when I first created it. And we identified it pretty early on. It just took a couple of users simultaneously adding Klipshows to the queue, and we saw this issue happen. So it took a little bit of digging, but I found this situation here in production where the Klipshows were having duplicate positions for a streamer. And when we first created this, we had validations in place that should have prevented this. But what was happening is the logic that took place for updating these positions weren't in the right place, and we needed to kind of just refactor this altogether. This didn't come up in the original development of this while testing it and stuff like that, because this is one of those weird edge cases where in a multi-threaded environment, we can have race conditions that happen where someone submits a Klipshow and the database receives it at the same time another request is performing an action on getting the number of Klipshows that are in the streamer's Klipshow, and that's where it derives the position number from. So in order to prevent this from happening, we have to make sure that no matter where the thread is coming from, Postgres will not allow this insert from happening if another operation is already occurring. That operation being what I just described, getting the count of all of the clips and setting the position of the current clip that it has a lock for. Now, we went over this in the streamer wallet transaction. We had the right idea here with how we're handling our transactions and keeping a running balance on the streamer's wallet. So it's one record that we're able to keep that on, but we still have all of the transactions that occur individually. And the way that we're able to accomplish that is by using Rails built-in with lock method. Now we're passing it an instance of streamer wallet here, and what this will do is at the database level lock that row in the database for the duration of this block here. So this opens up a transaction in the database. It creates a lock, a mutual exclusion, or mutex, you'll hear it referred to as. And what that will do is flag any other requests as saying, hey, you have to wait or block until this mutex is released, and then this request can go through. And it makes sure that in a asynchronous environment that we're getting a synchronous effect for situations like this. Now, as far as I can tell, the streamer wallet is working great. I haven't seen an issue with this yet, and I think that we nailed our implementation here. The reason I went over this is because in our streamer clip queue model, this is where the tweaks had to come in place to fix that issue. So we added a rebalance positions method, and we're keeping this set next position on create. That'll make sure that any new clips get set with the right position. And then after that, updating whenever a clip is destroyed or when it's moved, we're able to have our rebalance positions method kick in, and this is where the magic kind of happens with fixing this. Now, we're using a similar method here, but this does not come with Rails by default. This is using under the hood what's called an advisory lock, and Postgres allows you to use this, and it delegates the logic of locking and unlocking the mutex at the application level. So how we're using this here is it's using the Postgres mechanism to lock that actual row. So we can lock the instance of this, and Postgres handles that internally. Postgres is handling when the lock gets set and when the lock gets unset, so that we can have this kind of synchronous logic happen in our multi-threaded environment. Now that works well, but we don't need to lock any rows here. We just need to have a specific logic. We need to have a block in a transaction execute and have anything that is going to use the same key of that. So in this case here, it's very important to notice this. This is going to set a unique key for that lock, and when Postgres encounters that, it will say, okay, this lock is still locked, don't execute the next transition. It will block the previous request to complete whatever transaction was originally queued. And then as soon as the mutex comes unlocked, it will allow the next position in queue when the transaction happened. This is like a really terrible way of explaining this. So essentially, when one request comes in, no side effects can be changed on the database until this mutex is unlocked. And it's up to our application to handle that. Postgres isn't going to set this or unlock it, but it will honor when the transactions are going through it, when a advisory lock is in place. Now, we're using this with advisory lock method. So in my research of figuring out how to do this and use an advisory lock, the kind of vanilla approach is to run the raw SQL commands to Postgres to set and unset this. But there's a little bit more logic in place with, having a transaction, and I really wanted to mimic the block that we had here. This is very simple and very elegant, and the approach that would have to take place without this gem would require you to write out these raw SQL statements. So I found this gem. It looks like it is very well maintained. It has active commits within recent. I took a look at it. It's very basic. It's just taking care of that logic and giving us an ability to hook into our models in like a Rails-esque way, like we are with the streamer wallet. So this allows us to call it within we're calling on the streamer clip queue class. It hooks into any active record class that inherits from that. So what we're able to achieve is this really sleek, very similar to our streamer wallet service here. And we're basically using a key that is unique based on the streamer ID. So when any streamer ID is passed in and a lock is created for it, only then will this locking mechanism take place and prevent this block from running. So this is what we wanted with this advisory lock, is we're not locking any specific table or any specific row. There's multiple rows that can be affected without other rows of the same table needing to be locked. And so it created a situation where the advisory lock is the ideal situation here. So we're just basically creating this and keeping this as a consistent key. It may even be useful to pull this out into its own method so that we can have it kind of like declarative, and we can keep it centralized. But there are two different positions that we're using this in the rebalance positions, which happens every time a clip is updated. So if we change the position of a clip, it will trigger a rebalance of all of the clip queues for that streamer. And then also when a clip is destroyed, so after it's been played or if it's been skipped. And it's important to notate here, you may be seeing, okay, how does this not create an infinite loop where, we're updating the clip queue here, and then we have an after commit hook to run this after the update method gets called from the Rails callback chain. So how are we able to avoid an infinite loop here? And it's a great question if you came to that conclusion. Using the update column method, Rails will not execute any of the callbacks. So it's perfect for situations like this where in an isolated situation, we need to update it and not create a infinite loop of these callbacks continuing to call one another. So that's how we're able to do that. And we are able to find the position of all the clips by just sorting them in an ascending order based on their created at column. We're calling each with index, which gives us the ability to have a built-in counter. And since the index is going to be 0-based, we just have to add +1 to it. And this works really well. Similarly to the set next position, this is only going to happen when clips get created for the first time. So whether it's the very first clip that's in a streamer clip queues collection, or it's a subsequent clip queue that was created at any point in time, this will get run. And we're using the same advisory lock because we're updating the position column, and we need to make sure that at this point in time, in the order that these requests were received, they get executed. And we don't want a multi-threaded kind of race to see who can finish it first, because we will run into strange issues like we saw in the GitHub issue that I opened at the beginning of the video. So in order to test this, we have to create some threads in Ruby, and since we are able to leverage Ruby's concurrency model to test this, this is the test that I came up with for it. So in Ruby, we're not going to get into the Ruby concurrency model in depth, but Ruby has what's called a global virtual machine lock. And anytime there is not any input or output that Ruby is waiting for on the C language side of things, nobody can access the Ruby stack. It's actually single threaded. But in situations where you're waiting for a network request to Postgres or an HTTP request, the Ruby virtual machine will unlock the global mutex and allow other threads to run. So if that doesn't make sense, that should be fine. I'll illustrate it here. So with our fix in place, this test passes, and I will demonstrate that real quick. Okay, so if we run our clip queue test here, or just the queues for the streamer clip queue model, we can see that it passes. So if I comment out this line that actually changes the position here, because we're expecting that the positions are going to be in contiguous order, and this checks for that, or sequential order, I guess you could say. So the test passed at first, and now if we run it again, which I think it ran by default, we can see the problem here. So we're queuing up 4 threads, and I'm just doing that by, in a loop, creating a new thread class, and just starting begin rescue block. We're creating a clip queue, and then if the thread failed, I want to know about that, right? So if like something got raised here, I need to know about that. And originally, this test was failing silently, and what I had to keep in mind was the connection pool for the database. So by default, I think we have 5 threads that are connections that are available, and each of these threads is going to take up one of those connections. So that's why I used 4 here. I just needed to illustrate it. 2 may or may not have it raise the same concern each time. The thing about it is, like, the more threads there are, the more obvious the issue will be. So each time that this fails, and we can see why, we have 1, 2, 4, 5, and then we expected 1, 2, 3, 4. So if we illustrate the block here, actually this may not be the best because we're still using a block. If we were to just comment that entire thing out, this might illustrate it even better. Pretty much the same thing. So I mean, it hopefully at this point this is kind of understood. I should create a diagram for this, and if it's something that we get any kind of desire to do that with, I will. But hopefully this illustrates that issue. The reason that was problematic should be obvious. We in a semaphore queuing system where one item has to complete, and then the completion of this item is what triggers the next item in queue, and that process continues as long as there are items to do that with. In a situation where the positions aren't sequential, this will create a problem because that's what our queuing logic is. So we got that handled with that, and I think that's a great example going over the advisory lock mechanism and mutual exclusions and how they work in a multi-threaded environment. Definitely an advanced kind of concept, but something that you need to be aware of, right? And then another issue that we had was with our integration tests not passing on GitHub. And this was actually a weird one because certain tests that tested the Anycable connectivity would pass and the other ones wouldn't. And so this was a kind of a strange issue. It ended up being a misconfiguration in the Anycable config file here. So I had to add a condition, and the problem was the WebSocket URL was set to Anycable test, which works in our test environment when we run it locally, because we're able to use the Docker host names here to have this map to the associated service. But because the CI service is running a bit differently, we have to account for that. So basically using that CI flag that gets set with GitHub Actions, we can have the broadcast URL, which ultimately was what was causing those issues, and this to be set accordingly. So when we're running it locally in our test environment, we can have this run. When we're running it in GitHub Actions, this will run, and we can confirm that that works. So from that issue, we were able to get this pulled. I kept working on the public profile branch, and I wanted to wait until we got the issue figured out with the GitHub Actions in order to merge it. So I went ahead and merged it. That kicked off let me see here. So when I originally pushed the last fix for this, our test suite ran, and we can see that it passed. It kept failing prior to, like we hadn't had a successful test run in our CI in a while. So seeing a green check mark there is great. And then when we merged it in, it ran our deploy workflow here, and that basically did our deployment to through Kamal and DigitalOcean and all that kind of stuff. So we have this working again. We figured out what the issue was. It was a strange issue because the tests were passing locally every single time for me, but every single time they were failing on the GitHub side of things, and it just took some trial and error to figure out what that was. And it's just one of those things. There's a lot of moving parts. We've got Docker locally. We've got Docker in our GitHub Actions now. Everything uses its different. We have Kamal, which is Docker based. So there's a lot of different things that could go wrong and do go wrong. And the only way that I found out in order to kind of like get through it and to make it work for you still is just to know the inner workings and know everything. That's why whenever you think about a front-end engineer or a back-end engineer, it's tough, especially in this job market, because you really need to know everything in order to get what works for you on your machine pushed into production, which is ultimately where the value is in the craft that you have. So we are doing good here. We've got the bugs worked out with that. We have another issue that happens kind of inconsistently with the clips are in the right order. The clip queues are in the right order, but they're not playing. And so I think that's a front-end issue with how we're handling the TikTok API. And another issue that we have is some of the times the iframe request shows like a 503 or something, an error code. And then again, that disrupts the entire queuing system because that clip never finishes. Therefore, it never enqueues the next one, and that's problematic. So we're going to have to introduce a fix for that. And another fix that we actually have that I forgot to go over, that we ran into in episode 7, was we're using the iframes as the only preview for all of the clips. And not only was that providing kind of a slow experience because that's just so many requests that have to load and execute before we even see anything. The early viewers that I was showing it to said, this is already running really slow, and it wasn't even anything that was on the Klipshow side. It was just how we had it implemented with the iframe thing. So clearly that was problematic, and we came up with a solution for that. So the solution that we came up for, I'll show first in staging, since we have so many clips already in the server here, and it'll show it a lot better. If you are just tuning in to this episode, go back to episode 7 and you'll see where the issue lies with the original approach that we were taking with the iframe and stuff like that. So we click on the clip queues here. There's still a little bit of a flash, but for the most part, these loaded pretty quickly, and they loaded especially fast for me because I'm sure they're cached right now, and we'll go over the implementation of this in a moment. But as you can see, this is just a lot cleaner. We may have a little bit of a styling issue here. I think I might want that a little bit. No, it's actually fine. I'm tripping. Never mind. I just notice stuff sometimes when I'm doing the recap videos. So these are still previewable. So like, for example, if we preview this one here, we click on it, this is the experience that we had before, and it takes a little bit on the preview, but that's totally acceptable because you're not going to be previewing every clip every single time, right? So we should stay within that allocated time. I didn't see any documentation on kind of like the rate limiting details on TikTok side of things. So it just seemed like, you know, a spurt in traffic for a specific IP address would cause that. And this is inherently going to prevent that, because if you even wanted to do that, you'd have to click play on each one of these previews. So we'll go into how we're actually showing the preview here. We're actually not storing anything different on our side. We're still having TikTok handle all of the CDN for, that stands for Content Delivery Network. So the bandwidth that it takes to take something like an image and broadcast it or send it over the wire to a browser is usually done on a content delivery network, or a CDN, and that can cost money, especially as we get more eyes on Klipshow and that kind of thing. So whenever we have the ability to punt that cost and that logistics, it's super nice. And we're using the Open Embed API from TikTok in order to get this preview. And there's actually two images here. One is the largest resolution that they give you, and then the other image is the non-blurred one out that's in the right aspect ratio and everything. So we'll go over that, the implementation, but I just wanted to show it first. It's a clear win. I haven't had any issues in testing this pretty rigorously with that unauthenticated or unauthorized issue that we're running into with having just the iframes as the previews, and we still get that functionality of being able to preview it before committing to sending it as a viewer or as a streamer. So let's go into the implementation details for how we made this preview work. So in the very first implementation of this, we just had one component, and we had it in the streamers category because that's the only place that we were using it. And I think we moved it to the shared components directory here. And the reason for that is because both streamers and viewers can use it. And so I try to follow that self-documenting approach of like, okay, this is the intent. This can be in more than one context. And we also broke it up into multiple components. So we now have a preview, and this is the component that you see at first. The magic really comes from here, which is the fetch embed data. So when this component mounts, what we have happen is, instead of rendering the iframe, we conditionally have this show another component, which is essentially the same thing as what we had before. It's the TikTok player, which is just an iframe. I'll quickly show it. The meat and potatoes of it is the same iframe that we had in the first implementation. The reason that we have a preview now is so that we can tap into this OEmbed API, and this gives us the ability to get a preview from the TikTok URL. And the only thing that's needed for that, we don't need any API keys. There's no authentication. That's where the O from OEmbed comes from, I think. All we need to do is pass it the source URL. So I actually was mistaken. We are storing something differently now, and I will go over that in a moment. We are storing the source URL for the clip, and the reason that we need that instead of the actual video ID is it includes the username of the person who posted it in the URL, and we weren't storing that before. So I just added a metadata column to the streamer clip queues, and I put it in here. So for the purposes of this, it's working now. There is a workaround where you're able to use just the video ID, but having the author in the URL was the first way that I did it. So I found out about the alternative way of doing it after I'd already migrated the database and kind of committed to this approach. And I don't see it as being a big deal to roll it back. So it's still a win, I'm sure, for the other integrations that we'll do, like for Instagram and for YouTube. We'll leverage this metadata column on the streamer clip queue record, which I'll go over in just a moment as well. But we have the source URL, and this is what was pasted in when the user created the clip. And if we pass that to this here in just a very simple fetch request, we're not even using the KS fetch because we don't need any of the CSRF stuff that does. We get a response from that. We get a thumbnail URL, and that's what we're leveraging. And we also get the title that we can set in certain circumstances. So in the clip library, where it doesn't belong to any individual streamer, it was uploaded by an individual streamer, we will show the title of the TikTok in order to give it some kind of descriptor. And the reason for that is the preview image by itself, it didn't look like it was really showing what that TikTok was. And that is the functionality that we had to kind of introduce to make up for what we had previously with the iframe. We had the author name and the a little preview of the description, and that was something that made it easier to identify the clip. So we substituted that with the title that we get from the oembed response. And what we do is we have that set up, and we're basically creating two different images here. So we have a background of this image here, or of this component here. So I just create a div, and we're having it set to the entire width, but making sure that the overflow is cut off so that it doesn't take up more height than what the actual preview will take up. And then we're just using the Tailwind CSS blur, and that's it. That's all that we really needed to do. And then the preview image here is what actually loads, and we just have some styling set up. We have a preview or a play button here, and when the play button gets clicked, we set the show player to true, and then that displays this component here, and then we set the disable preview to false so that they don't show at the same time. And then this just works almost identically the same way. As soon as it mounts with the props that we pass into the preview, so that we don't have to render both the player and the preview in the page, we can just render this and conditionally render the player. And this also worked well for the alert consumer in OBS, what actually displays the TikTok in OBS. So we are able to just use the TikTok player for that and then combine it for the preview, which I think makes total sense. So we're passing that autoplay prop to the TikTok player, and then once it mounts, it will automatically play, and it seems to work well. So we'll keep that in mind for the YouTube and Instagram and other integrations if and when we get to that point. But this seems to work well so far with getting over that preview issue. And that's just the name of the game. You've got to just figure out where the issues are going to lie. This wasn't really a documented thing when I created my initial design proposal for all of this. So we have to roll with the punches. I'm very glad that we came up with a solution that doesn't require us to store the thumbnail ourselves or anything like that. It's something that we can just tap into this and not have to worry about adding really any additional infrastructure costs. So on to the next thing. I think we're going to add, we're running into an issue that happens sporadically with the queuing system breaking and not showing the alerts. So we may run into that and divide some attention to that. Otherwise, if you see where the cursor is, not actually in VS Code here, but I'm thinking we'll add like a window here notifying the stream of who triggered a Klipshow, so that you know that you can see that. I noticed from a streamer's perspective, it's nice to do that without having the queue up in front of me. And so we might work on that. And once I have some more ground covered, I will see you in a moment. But hopefully this is making sense. And I know I'm rambling an awful lot, but if ever you have any questions, the Discord is great. I'm streaming live right now. So I stream live pretty much every day. Come in, ask me questions about this stuff, and I am happy to help. Till we get some more functionality figured out, I'm going to go heads down, and I'll see you in just a second. An issue that I started running into while using Klipshow in my own streams is that while leaving the iPad on overnight and coming back to it, when I start up the stream, it appears that everything is going to work. But when I go to add a clip queue, it gives me an error. And the reason for that is we have some authentication in place for each request to these privileged controllers to make sure that the streamer's OAuth token isn't expired, and we're not doing anything to automatically refresh that. So I have a proposal here that I think should work with what I want to have set up here. And I want to base this off of their persistence with the WebSocket connection that they have. So when they go to a particular section in the dashboard, I think it would make sense to have that mechanism tapped into to see if they're still connected. If they are, if there's still a persistent connection, that should be enough work on their side for us to go ahead and refresh their OAuth token for them. The overhead for this shouldn't be too difficult, and I think it will provide a better user experience because I see this being something that every other streamer is going to do. Just leave their Klipshow tab logged in and in between streams without having any other notification that they need to relog into Twitch, which really shouldn't be necessary to begin with. If ever they have any issues with their authorization or anything, saying they can programmatically disconnect Klipshow's access and force them to sign back in if we need to. So it's not like we're taking away the control that a streamer would have in the event that authentication was misused or something like that. So the idea here is anytime that our connection class gets called, there's a connect and a disconnect hook that we should be able to hook into. And during these times, I'd like to set new columns that we're going to set up on the streamer table for tracking this connected state. So I'm thinking we'll have 3 different columns in order to track this: last connected at, last disconnected at, and is connected. So the first 2 will be datetime columns, and that'll just be nice to potentially be able to track user session history and that kind of thing. And then the is connected column will be the column that we look up to see in our task that we'll have run on a recurring basis to see, okay, all of the streamers that have this column set to true, go ahead and go through to see if we can automatically refresh their OAuth token for them. So we're going to introduce a new migration to the streamers table, and then we're going to introduce a recurring job that we'll have run every 30 minutes. And every 30 minutes, we'll check to see all of the streamers that show an is connected column of true to see if their OAuth token is going to expire within 30 minutes. If it does, we'll go ahead and attempt to refresh that for them automatically, and we should be able to fail gracefully by having all of these be asynchronous. We're actually going to have 2 different types of jobs here. One job that will be like a supervisor or like a dispatcher, and then each individual job will have its own worker or its own job that it can isolate the work in to actually refresh the token. So we're including redundancy. We're adding the ability to even from the console, see how many streamers are connected very easily. And we're not really having to write anything super special to make this work. We can persist these columns very easily with a migration and then hook into these connect and disconnect methods that Anycable will ultimately call when streamers connect and disconnect. And this all should work really well. So this is the proposed solution from kind of a high level. Let's go ahead and write the migration for it. So I've added a migration here. I've just called it add connection tracking to users, and we're adding this to the users table. So that is why we're saying that. And I'm mentioning that because we're using a streamer model, but this will also be applicable for users too. We're not needing to build out the use case for that, but since they both operate on the same table, that is the nomenclature we have to use here. So we're just using the add column on these for the users table: is connected, last connected at, last disconnected at, and their associated types. And then we're also adding a index to the is connected column so that we can do a efficient lookup for all of the streamers that have this set to true. In the situation here where we're adding an index, we need to use the concurrent algorithm to build that index. And in order to have that run, we have to disable the migration from running in a transaction, since that does not work. So that explains all of the migration. Now we'll need a job that will be able to run on a recurring basis using our existing solid queue setup, and that job will ultimately dispatch individual jobs for the streamers that meet our criteria. So we've added a few things here. I have a main job that will be what we directly have set up in our recurring.yaml file, which we'll get to in just a moment. And this will be set up like a cron job. It'll be run every 30 minutes, and solid queue is going to take care of all of that for us. One of the nice things we get to take advantage of with that right out of the box. So this job is just going to get all of the streamers that we have a custom scope for that I'll also show you in just a moment. And this is going to use a new scope that we added called connected that just checks to see if that is connected column is set to true. If it is, well, that's just part of the query. And then we also, on top of that, query their OAuth refresh expiration and see if that meets our criteria as well. And we're just using this refresh window constant here at the top, and we're setting that to 30 minutes, and we're calling 2i on it so that it will put it to seconds so that we can use that in a consistent way. So this will get us a collection of all the streamers that meet the criteria to have their refresh tokens automatically refreshed. We're just doing some nice little logging here for this. and then going through each streamer and enqueuing another job that we just wrote for refreshing the actual streamer. So that job is here, and all it is a wrapper around our OAuth refresh service that we already wrote and are using for our original authentication. And the reason that we have this wrapped in its own job is this can fail independently now, and we don't have to worry about clogging up the rest of the queue. Each job will be enqueued a lot quicker and be able to run in parallel as well. So as this grows, that parallelization will really matter and will pay performance dividends in the future. So yeah, we're just taking a asynchronous approach there, having it wrapped, and then we have some specifications here, or some specs set to just basically test all the stuff that you would expect, that Twitch service gets called from the wrapping job that it's in, and then the refresh connected streamers job does the same thing. When that job runs, we need to ensure that all of those jobs get scheduled individually when they need to, and then we ultimately set this up to run on a recurring basis in the recurring.yaml file that is stored in config/recurring. So based on the sample that Rails ships with here for you to go off of, it follows a very clean approach here, and you can basically namespace each of these and have them run for production and development. I don't know if there's a better way to do this as of yet if you get like a lot of recurring tasks going, but I don't think we need to worry about that anytime soon. Very self-explanatory. You just define the class that it is running, the queue that it's running in, and then it uses, I'm sure, like a natural language processing for time parsing, like something like Chronic or something like that, which is really cool. So schedule every 30 minutes. And yeah, we have that set up to run in production and development. And as long as we have an instance of solid queue running in the instance right now that we have all of our services running in one box, that is the same thing. It will be set up automatically, which is just so nice. One of the really nice things of having this in-house and not having any other dependencies to make it work. And then in our connection class here under channels application cable connection, this is that connect and disconnect method that will get called when the mechanism is engaged from Anycable for the corresponding actions to take place. So when a user connects is when this method calls, and then subsequently when a user disconnects, this will happen here. And this will happen automatically because we're doing it on the Anycable side. So if Anycable isn't able to ping the user or the heartbeat breaks, this should handle that, and we don't need any additional logic for that. We're tapping into the existing functionality for having, you know, our functionality in place of when these events actually happen. So when the disconnect happens, we just call some similar convention method here as to connect. So it's track connection or untrack connection. And we basically just update those columns that we populated based on if they're getting connected or disconnected. Very self-explanatory here. And then I'm logging this out just to see if I can, you know, make sure that this is working on a recurring basis. So that seemed to make sense to keep that there. All right, and all of our specs pass for this, and I had Claude write them, but I reviewed it and took some of the stuff out. Most of the stuff was right. Very simple stuff as we went over, just kind of briefly. That's the nice thing about our spec is it's like really easy to skim it and just make sure that this all looks correct. And, you know, sometimes it's a little verbose with the comments and stuff like that, and doing weird stuff in the test. So it is definitely something that you need to monitor, but overall it is really nice to have that. So since the specs are passing and all of this works in theory, I'll go ahead and actually deploy this to staging production. We only have one environment right now that's hosted somewhere. So I will get this on a pull request separate from the one that we were just working on, and then this will go ahead and go out to production. So that was actually a really quick rundown and implementation of all of this, and I think a great thing that helps me because I'm so scattered with my thinking is using Claude to help brainstorm existing functionality and making sure that a approach that I think will work can work, and it's almost like having another coworker or something that you can bounce ideas off of. So I've been using it like that, and I think this is a great testament to using it in a good way, monitoring everything and making sure that it's following the patterns that you have set out, and then kind of taking advantage of that. So we will move on to the next thing here that needs to get taken care of. I just wanted to get this done because it was something I was noticing. I think the next thing that we're going to work on is probably introducing the little notification that can come up when a clip is triggered on the actual stream. There may be other things that we can work on besides that, but as of right now, at this point in time, that's what I think we're going to work on next. So I will see you in just a moment. I just wanted to tag on here that after we deployed this using our GitHub Actions flow, we needed to rerun it because we're having a Ferrum connection timeout. That's the only thing that seems to be flaky with our GitHub test now, so we'll have to investigate that. But rerunning the test on the pull request passed, and I wanted to actually show what that looked like because I want to give everybody that doesn't have an opportunity to see what the flow is for, development and stuff like that when you're on a team or something, just giving you any kind of idea for those that are brand new to it. So I created an issue here and I just basically described it. And I was a little verbose here if you want to pause this and read kind of what I wrote. This is a story or a ticket that I would write probably pretty close to this, maybe a little more detail if I needed to. But I took this issue here and we created a new branch from the master branch, and we just called it connection tracking. We opened up a pull request on it, and I mentioned the issue number here, and that links this pull request to that issue. And once we have a new branch pushed, GitHub will automatically detect that, and at the very top, I should have recorded it, but at the very top, there'll be an option to compare and pull request the latest branch that was pushed. It's kind of a nice way to do it. Otherwise, you have to go to pull request, base, and then whatever your new branch was. So in this case here, it was connection tracking. There's nothing to compare because it's already been merged. If it was different code that was on master versus this branch here, we would be able to create a pull request. That pull request then has the CI workflow run against it. And here is the one that passed. So we ran the linter, the brakeman, and our test suite. That passed, and that unlocks the pull request to be merged to master. And we have in our workflows set up a rule to anything that is merged onto master to have the deploy action occur on it. And that ran the very first time, and it took 4.5 minutes. Not too bad. I'm not sure why. I expect it to be faster than that. I'm sure we're not doing something with like the Docker image caching or something like that, but even still, it's really, at this stage, it's not a big deal. But this did run, and our post hooks ran to migrate the database. As you remember, we had to add a migration. That ran, and I confirmed that that ran by doing the Kamal console in my terminal here, which is the same thing as running a Rails console in the box that it's running in the Docker instance, that is. And then I made sure that these fields are there and that they are showing and being populated as is expected. So this looks to be working. And the last piece here that I wanted to show was the recurring tasks. This all just works with that deployment process. It's showing up here. It's going to run in 18 minutes, which I have full faith that it is going to. This is a phenomenal example of getting this up and running. It's a great testament to Rails and just these things working together so quickly and not having to spend a whole lot of heartache to have so many different things work and just work well together. So wanted to give a shout out to that and give an idea of kind of the flow from issue to having it pull requested and QA'd a little bit and everything like that. So on to the next thing. Well, it's been a few days since the last recording session, and I have some work finished here and some specs passing, and I figured I would do a check-in. So all of that work for the recurring job that we had for renewing the Twitch OAuth expiration, I went ahead and pulled out. And the reason I did that was it dawned on me that we don't need a Twitch access token every time that a user is interacting with just Klipshow. We really only need that if we're going to be using the Twitch API. So I went ahead and changed the logic in our authenticatable concern here and basically just switched this around so that it doesn't check for the OAuth expiration. And then I removed the recurring jobs and just commented out the declaration here so we can use it as a reference in the future. So it didn't take too long to get it up and going, and maybe we'll pull it back for another reason if we find a reason to, but I just think that I was overcomplicating this and overthinking it, and so we have that pulled out now, and I've tested this and left my iPad signed in with Klipshow overnight, fired up the stream the next day, and it worked without an issue. So that confirms to the greatest extent that we can that this actually fixes it, even though we did take a bit of a roundabout approach to doing it. So at this point, I think we'll start looking into either the alert thing that we're talking about, or the kind of like the better error handling for the alert consumer. Sometimes when a TikTok displays on stream, the iframe returns a 503, so the iframe on the screen is just showing an error, and it stays up there until you refresh the screen. So clearly that's not ideal, and it only happens every now and then. I'm not exactly sure what would be causing that. So what we are going to do is work on that and probably the notification first. I know I'm kind of jumping around, but things are picking up work-wise and everything, so I'm having less time to consistently dedicate to these videos. But I'm still getting them out there. We're still going to get this finished, and hopefully get this in front of some real streamers real soon. So status update on that. We did pull that out, and I'm very happy with that because I think it's going to make things simpler. I think it was just an overthought on my process, on my part, and we will move on. So I will see you in just a bit. Alrighty, checking back in with all of you there. We have a new solution in place for hopefully adding some redundancies for the iframe here as it loads. So in our TikTok player React component here, we added a few things. So I changed the player ready to show a hidden class if it's not ready. So this should help it with some of the TikTok, like at the very beginning, it not like just starting on the video. It should just be kind of an improvement, not super related to what we're doing. But the real meat and potatoes here is just the wrapping around the player ready state. And then I have this additional thing here for, we're going to give this 3 different tries. So basically what happens is we render the iframe. These conditions are by default true. So this block renders here. This block does not render. And then we rely on the iframes on load event to start a timer, and that timer will incrementally have the iframe not rendered and then re-rendered to start this process over again. And then we'll keep track of the counter in a ref here in React, and I'm just going to have this set to a constant at the top here for 3, and then I also set the load timeout to 500. And with config options like this, I like to set them at the top of the file like this. It seems pretty declarative and helps understand what's going on. So basically right now we're going to wait 500 milliseconds, and if this timeout executes, it will de-render the iframe, re-render it, and start another timer. And if that happens 3 or more times, then we stop the loop. We just don't show this block of code altogether, and then we'll show a retry limit. And we'll see if that's something that we run into. Typically, when I have seen this issue in particular, if you refresh the browser source in OBS, forcing that iframe to reload, the TikTok will then render. So hopefully this will be a simple but meaningful fix for when those situations happen. So if we don't see those gateway timeouts now, then we should be good to go. That reminds me, that's actually another reason why we have the player ready hidden. So this will prevent the 503 timeout from actually displaying, because the iframe will be rendered, but it won't be displayed on screen. So this allows for the this retry logic to happen without like that TikTok player flashing with an error message. So that's another reason for that. So this is an improvement to that, and hopefully it's pretty self-explanatory what we're trying to do, just using this pattern of setting a timeout, and then in the, I actually didn't go over this part, so my apologies, but what actually, it's a race. As soon as the start timer function executes, we have 500 milliseconds before this block of code executes, and that block of code is what re-renders the iframe, and it's going to take longer to render the clip if we have that happen, right? So we don't want to have that happen unless we absolutely have to. And what will cancel the timeout is in our onPlayerReady message that we get from TikTok in the event that the TikTok JavaScript and everything else loaded correctly. And we can call the clear timeout method on the return value of that timeout, which we're doing with a ref here. And that will prevent this from getting executed, because if we got here, that means that the TikTok player loaded, and that is our strategy around being able to detect when the iframe may have not loaded or whatever. This should be fairly robust beyond just that 503 gateway error. If there are other errors as well, anything that basically prevents this line of code from rendering before the timeout runs is what this will account for, and giving it 3 retries should be sufficient. So we will go ahead and deploy this. I'm going to try to write a spec around this, and I'm going to try to mock the request that's sent to the TikTok iframe and see if I can emulate that happening. And I'll give that a modest amount of effort because I'm not sure exactly how well that will work. But beyond that, I've tested it locally here, and we will go ahead and deploy this and start testing it in staging/production. So until we get the next thing figured out, I will tune in then. I think what we're going to do is start working on the notification at the bottom right, because I think that would be really cool. Seems official. We have the ability to see who played the clip on the streamer dashboard side of things, but we don't have the notification for the rest of the stream. So we'll go ahead and add that next, and that will add some more functionality to the alert consumer in OBS for the streamers, and we'll add some more stuff. So I will check in with you in just a moment. Okay, I have to check in here. I'm not sure where we are in the series or on this episode because it's been a little bit, and I've had a few, but that's neither here nor there. One of our dedicated and very meteoric rising developer that we are blessed with in the chat found an issue, actually serendipitously at the same exact time that I found it. He just found it in a different way, and I will illustrate the issue that he found here. So we have a clip, and I'm going to edit the title of the clip. And as you can see, each time I type, we are making a request to the TikTok oembed endpoint. Now, what would cause that? Because this isn't an issue when we render the preview elsewhere. At least I don't think so. So the issue actually is in our TikTok preview component here. I had the fetch oembed data function just in the regular rendering instructions of this component. The reason this is wrong is we don't want this to render each time that the component does. We want this to render once within the component's lifecycle and then not render or not change anymore. So in order to fix this, we will add a use effect block here, and we're going to give it an empty array of dependencies, and that will prevent this from happening. We'll go ahead and save that, clear our network log here, and if we type in, we can see that this is not actually causing that fetch oembed method to be run each time the component re-renders, because this component is trickling down the effect of having the TikTok preview re-render, and that was causing the issue. So that is one of the issues we've been running into. Another issue has been where the TikTok previews will just stay in their loading state. So the spinner will just show, and the what happens in the background is the oembed request fails. And based on a few of the users and myself that have seen this error intermittently, it seems as though the oembed API is not meant to be hit from the front end, but instead just from a back-end server. So what happens on a front-end request is there's a pre-flight request that's made in Google Chrome to make sure that the endpoint that you're trying to hit over this AJAX request is set up correctly with CORS, if it the cross-origin resource sharing. And if it returns the correct headers, it will let the actual request go through. And that's ultimately, I think, what's causing the issue, but I'm not sure why it's an intermittent issue. So talking to Cursor about this, they are saying we should create an endpoint where we just have it wrapped around the oembed API request itself. So I'm not super wild on that, but although it's an easy solution, it's going to be a lot more requests that we're going to be hit with, but I'm not super concerned about it because we'll start to introduce things like pagination and making sure that only the URLs that are needed are going through. And as I'm saying this out loud and kind of thinking about some of the pros and cons of this approach, this could potentially be a phenomenal opportunity for adding a caching layer with solid queue, or excuse me, with solid cache. So I'll do a little bit more research on that and see if this is a good candidate for it, and see if we can prevent having those HTTP requests go through. And this just might be an easy win because we're already kind of positioned to take advantage of the solid adapters that Rails 8 ships with. So yeah, as I'm thinking aloud, I'm starting to get less worried about this because we might be able to introduce that, and that will decrease kind of the overhead and stuff like that on having this happen each time. So since we were kind of derailed with this issue and we know it's preventing the use of the application now, I think this is something we need to prioritize over having the like notified, the little message at the bottom right of the screen showing who triggered the clip when they play. So we'll get this taken care of, and this is a nice segue. This is just kind of how this stuff kind of works sometimes. So we will introduce this. I'll deploy it to staging, and I'll have a few of the viewers, if there's any around at the time, test it and see if this works, and I will report back shortly. Happy Halloween, my fellow developer friends. We're doing our very first subathon today. It is the 1-year anniversary of me starting to stream. I've been very consistent at it, and it is definitely something we're celebrating. So for the rest of at least a little bit of this portion of the episode, you may see me dressed up like this. But we will get back into the code. Trust me, that is what the focus still very much is. Now, we have some issues going on with Klipshow. Let's go ahead and go over this because I'm not sure where we left this last time. So the biggest addition that we had to kind of pivot on in an impromptu manner was this OEmbed API endpoint, and for TikTok specifically, and I'm sure we'll need this for the other ones as well. But because the cores isn't supported from TikTok, I think that's what's making this necessary. And I say I think because the issues that we're running into with having these preview images load is inconsistent. So I'm just going to go this route with it since there's no official support for cores with the TikTok API. And this seems like a better alternative, and really this will provide better performance and a better experience for the user ultimately, because we should be able to have the round trip on these requests be faster because we're implementing a pretty robust caching strategy. So this is the first thing that we're using solid cache setup with. We already are using solid queue, and that is working really well for our background jobs. Now we're going to take advantage of solid cache, and the nice thing about doing that is we get to just tap into the existing Rails API. So regardless of if you're using Redis or Memcache, you'll use the same mechanism. The idea here is you'll have a unique key. If that key is in your cache store, it will be a cache hit, indicating that this block does not need to run. And this block is where we actually make a HTTP request on the from our server to the TikTok API endpoint for the OEmbed stuff. And so we're not going to be able to get around having to make this request at least once, but once one user makes this request, I'm being very rigid with my strategy here. We don't need to change the cache if the description of the TikTok or anything like that changes. Really, we just need a preview image. So I'm setting this up to cache basically forever, both in our database cache, and then we're also using an E tag here. And an E tag is another way to potentially prevent a user from even having to hit our cache store by having a E tag assigned to this response. And what an E tag does is allows us to set a unique string that we can compare future E tags against. And if they match, we can have the response return a 304 not modified, which will tell the browser to use the existing cached response that we have for this. So if any subsequent request that a user makes, an individual user or another user requesting the same TikTok URL, will have this flow happen. So as soon as somebody hits the cache here and they don't clear their browser history for the duration of them not clearing their browser history, they won't even make it to the rest of this code. It'll literally return right here. And that's a really important strategy, I think, for something that can scale. This is also something that is not locked behind any. This is also not a authenticated controller. So basically, this is open to the entire internet. And the reason for that is we have to do that for the public profile view for these streamers, because viewers can still see the TikTok previews of the clips that they have enabled, even if they're not signed in. So just trying to take into account all of the good stuff here. Another thing that we're doing is we have a kind of a check here if the TikTok URL is not valid, and we're just using a regular expression to match that. So if they're trying to patch in something else that will get sent to TikTok, we're going to combat against that. And I think this should leave us in a pretty good place for now, other than we're running into some issues with our tests. So our integration tests were working completely fine, and then they started failing. One of the reasons that they failed was we had to update our factory for the clip specs, for the clips actually. So this is the library, or this is the factory that we're using for the clip model. And I basically had to add the metadata field to include the source URL. And the reason we needed that was because the React component uses this property here to send the request with the URL to our TikTok endpoint. And that's where this URL comes from in the params here. So that was the first issue that we're running into. We got that fixed. And now the request on the back end is being made to TikTok. This is what we want. But in a testing environment, we don't have a consistent cache store. We don't want to have a consistent cache store because we want everything to be tested anew each time the test suite runs. And so it puts us in a precarious situation where we have to make a decision. Now, we've been using WebMock before for all of our testing that we've done that surrounds external HTTP requests. And that's certainly something that could work here. I'm going to introduce something else, though. I'm going to introduce something called VCR. And it's a very helpful gem that you can use for situations just like this, where you don't necessarily want to mock the request yourself. It can get tedious. Maybe it's not as thorough with mocking the entire body of what gets back, and it can be there's a time and a place for just a simple web mock, regular expression, wildcard URL kind of approach. But then there's something like this where I think it's a useful enough case to introduce something like this and get you thinking about how you may be able to introduce this in your testing if you're not familiar with this already. So what VCR does is it allows the very first request that the test will execute to get past WebMock, and it will actually perform the HTTP request, and the response that we get from the third-party HTTP provider will then be created. We'll then have a fixture created for it, much like our factories, and VCR just does this on the fly. So it's almost like our own caching mechanism. We just went over how the Rails API works for caching a key and the situation that occurs with executing a block if there's a cache miss or the cache key is not in your cache store. And that's pretty much the same approach that we're going to have here. VCR use cassette is the syntax that you'll use. You'll use some form of unique identifier, usually something with a version number in it so that you can manually break the cache if you need to, because although I said that we don't have a consistent cache, I guess this would kind of be a cache that is stored on disk and is stored in the repository and will be loaded each time. So technically it is still kind of cache. I guess I was mistaken in explaining it that way, but we're going to go ahead and introduce this. This should work fine. The setup for it is very simple. It's designed to work with WebMock, so all of that stuff should work. I'm going to go ahead and add this gem now, and we are going to introduce the VCR stuff around the situation where we're testing clips that have that O-embed request that will be eventually made. So we're running into it specifically with integration tests, totally understandable. And yeah, that is the strategy for both the caching and hopefully getting around the original issue of TikTok not supporting cores on their endpoint. So they apparently don't want you being able to make requests from a browser, which is totally fair. So I'm going to go heads down here. I might have to take the shades off to see a little bit better. But I just wanted to go over that, and if I run into any situations that need a call out, I'll be sure to flip the camera back on. But until then, I'm going to go write some code. I'll be right back. Okay, so we have made some progress here. We should have all of our tests passing. We did just have to track down a test that was failing inconsistently, and I think the reason for that, it was in this test. It was in this spec here. We were doing this, and I had this call to set the clip price. So this is when you're adding a clip, it's a kind of like a wizard. The page doesn't change or anything. It just changes the overlay to where you fill out the rest of the fields. And I had this outside of this block because I don't know. I don't know why I had that, but I changed this to be in here. It passed a couple times consistently on its own. I have yet to run it within the context of the entire test suite because that's what was happening before. But that is somewhat unrelated to the VCR stuff that we're adding. So I have VCR added. In order to do that, we just added the gem VCR. And then because we should have a volume for Docker that shares the bundle cache locally, so we should be able to bundle locally, and then the gems that actually get installed will be just virtually mounted in the Docker services. For some reason, that's not working, so I had to restart my containers to do that, part of which bundles the gem file on startup. But anyway, just figured that was worth mentioning. The other situation that we have here with our VCR is just the configuration. So I did have to add a few things here. By default, it does give you the cassette library directory. I changed this. It was following more of a mini test-esque directory structure, and I thought this would be a little bit more in line with our spec instead. So I'm putting them in spec, fixtures, VCR cassettes, and you can see that here we have it automatically creates these YAML files, and this is what that response is that it's caching, and I'll go over that in a little bit more detail, but this is where those are getting created, and that is happening automatically. Another thing that I had to do was ignore localhost. So this includes